Graphene, that wondrous material that has amazing properties in the nano world, and yet we've been able to extricate those into the microscopic and the macroscopic worlds in order to realize applications. I'd like to introduce you to Sanjeev.
Hello.
Sanjeev has been working with us in developing and discovering new aspects about the chemistry of graphene. What's particularly important is that we modify the chemistries so that we retain all the amazing properties of graphene, the amazing mechanical, electrical properties, and even biological properties, and yet we make it processable. That is, we can take those fundamental, very thin, small sheets of graphene and make them into structures and into devices. Starting with the discovery of graphite, or the mining of graphite from a natural source, Sanjeev, can you tell us something about the importance of that source of graphite?
Yeah, definitely, Gordon. This is the very high purity vein graphite from Sri Lanka, which is mined, and it is 99% pure. So what we are doing is we are starting with this graphite and making the flakes of this material like this one. And after making the flakes, we are intercalating this material. Between the pi stacking, we put the intercalants. And
so
then,
just going back to taking the graphite,
yeah.
So we take the lumps of graphite from a mine.
Yeah.
How do we know how pure that graphite is, or what the properties of the graphite?
We have been characterizing this material by CHNS analyzer, how much is the purity of this material, and also checking the impurities by trace metal analysis, how much is the metal impurity, which are very, very important, how much is the impurity content in this one. Once we ensure the quality, then we start processing the material.
And so we take this lump of graphite,
yeah.
And what's the next step? Is it to exfoliate it into different...
First to make the flakes out of it, and then intercalate those flakes.
So how do we get from here to the flakes?
It is just by manual crushing at this stage. We are controlling the mesh by sieve filtration. And then we do the intercalation of this material.
And that intercalation involves putting other ions between the sheets of graphene in these flakes.
These intercalants need to be of very high boiling nature, because they need to stay within the pi space of the graphite. So we have been optimized, like orthophosphoric acid, nitric acid, and sulfuric acids are the main intercalants which we have been using for integrating the graphite.
So we take this lump of graphite, we grind it into flakes, and then those flakes have multiple sheets of graphene,
Absolutely.
And you're putting ions in between those sheets
Absolutely
of graphene.
Right. Yeah, that's
and then
right.
The next step would be?
Then we give a rapid shock, thermal shock of this to this material, so that it pops like popcorn. The volume expansion here, this is 2 grams of material. The volume expansion is between 700 to 900 times. So this much of material expands to this much of volume.
Wow.
So this is such a high expansion of this graphite. Once at this stage, now 7 to 9 sheets of graphene are stacked together. The surface area is very high. Now we can very easily chemically oxidize this material.
Right, so now we've got this thermally expanded material, and we're going to chemically oxidize it. And does that cause it to break up into the individual sheets?
Absolutely. This is what we have been getting. This is the graphene oxide, which is a very large sheet of graphene oxide, around 50 to 70 micron sheet, which is having a unique property, forming the liquid crystalline nature of the material as well.
So people might think, of course, that 70 micron is not particularly large. But it is. I mean, we're talking about a 70 micron sheet. That's a bit bigger than the diameter of a human hair. But remember, we're talking about a material that's 1 or 2 carbon atoms thick, right?
Yeah.
And so the aspect ratio of that is huge.
Absolutely, very, very huge. Yeah.
And that's what causes it to form those ordered structures in solution, or what we would call a liquid crystalline solution,
yes,
right?
Yes, that's right.
And then what would you do with that once you've got that form of the dispersion, Sanjeev?
So we have been using this material for a variety of applications, for spinning the fibers and for coating onto the fabric. This is one example. We have coated this material simply onto this fabric. And this fabric is very conducting, as you can see. It is conducting fabric just by simple coating and reducing the fabric.
So you take our dispersion, which is the graphene, and so this fabric is coated simply by dipping into the graphene solution?
Simply by dipping onto the dilute solution of this material. And after that, it's reduced. Because graphene oxide, there is a lot of defects onto the surface. We restore the aromaticity, and it makes the fabric conducting.
And as Sanjeev mentioned, these same dispersions are what we use for fibre spinning, for creating long lengths of individual fibres, as well as for printing, either in 2 dimensions or 3 dimensions. And we're going to be looking at these processes in later parts of the tour. It's really important that all of those chemistries that we've just been talking about are actually scalable. It's one thing to be able to do chemistry on a bench at a milligram scale or a gram scale, but be able to take those same chemistries and process graphene into tens of grams or hundreds of grams and still retain those special properties has other challenges. So Sanjeev, can you tell us a little bit about the challenges we encounter in scaling those processes for graphene?
Yeah, Gordon, on the laboratory scale, when we are doing the oxidation, we are creating defects, we are putting oxygen, and the material after oxidation is insulator. So how many oxygen functionalities we put in? Now we have to, when we are scaling it up, we have to produce the similar quality what we were getting on the laboratory scale, and that's how we will get the final product which we were using before. So it is very important to optimize the parameters here. So the parameters were easy to operate on a laboratory scale, but it might be difficult to operate it here. So what we have been doing is we are optimizing the conditions of the reactions so that we get the similar quality what we were getting on the laboratory. So there are so many parameters which are involved, so we are optimizing one by one.
So I guess that's why it's very important when we're working on the bench that we keep everything as simple as possible, yet try to maximize the properties of the graphene and the processability of it.
Absolutely, you're right, Gordon. So it is important at that stage as well, the critical parameters, or monitoring those parameters which are critical, and then very careful implementation here to see how effectively we can optimize here as well.
And of course, if we're going to explore different methods of fabrication, the quantities that we make on the bench are never going to be enough, even to explore all the different methods of fabrication we'd like to, right? So scalability is really important.
What we have seen in past as well, Gordon, when from batch to batch variation in the laboratory, but once we process larger quantities, there is minimum batch to batch variation, and we can do very effective research using this material from the same batch. And once we optimize this on this scale, after this scale, we can say the technology is scalable. We can go to industrial scale, because at this stage we are doing the reactions at 35 liters. And from 35 liters, taking the batch to around 500 liters or 1000 liters is not that difficult once the parameters are optimized.
So in meeting the needs of our experimental program in terms of exploring fabrication, we're also really making this process ready for industry, ready for manufacturing.
You're absolutely right. So once we are confident on that scale, we can definitely go to industrial scale manufacturing.
Great. Well, we're going to go and have a look at some of the different fabrication methods, the fibre spinning and the printing and the making all of these amazing devices for energy and biomedical applications. So thanks to you guys down here for showing us what we do at a very fundamental level in the chemistry of graphene and how we make it scalable.
Thanks. Thank you.